Hey everybody, this is Larry. This is me doing the weekly, week 2 of the weekly premium challenge. Hit the like button, subscribe button, join me on Discord. Let me know what you think about today's poem. Today we're at 490, the maze. I don't know. Let's take a look at what this maze holds. Okay, so there's a board, empty spaces, up, down, left, right. Won't stop until it hits a wall. When the board stops, it could choose the next direction. Alright, I mean, this is basically, are we doing the what is it asking for? It's just true false. I thought it was going to be like minimum number of moves, and if it was the number of moves, I was just trying to figure out whether it was the number of kicks, if you will, versus the number of spaces. So that's what I was looking for. But it turns out that you just want to return true false. Okay. Yeah, I mean, I think then in that case, we can just do a straightforward BFS, right, on each cell. And just that we limit the, we limit until we cannot move anymore, right? That's basically the idea, I think. Does this one, you have to stop at the, that makes it a little bit, maybe not, maybe that's fine, actually. It does make it a little bit trickier to think about, but I don't think it's that bad. So yeah, I think we can do it with BFS. So let's get to it, right? You just have to be a little bit careful about how you think about the invariants. Yeah. Okay, so, start, they actually give you the start location, okay. Okay, and then destination as well. Okay, fine. Yeah, and then Q. And we don't need spaces, or like we don't need like a shortest path holder thing, right? What do we need? Maybe that's it. Well, I mean, we need to hold like a Boolean thing if nothing else. So. Yeah, I mean, okay. So what we want is for each cell, there's 5 states, right? One is up. One is that it's stopped, and then one for up, down, left, right, and then it just keeps going. So that's kind of. Sorry, I'm like coughing. I have like a really sore throat. But yeah, okay. So then now we write. But we can also just do a set, right? Like maybe scene, maybe we'll optimize it with an array or matrix. Oh, jeez. Jeez. Louise. Oh, what is going on with my... What is that? No. Yeah. Sorry, friends. Technical difficulty. Okay, what do we want to do? Yeah. So I would say maybe I'll convert it to a matrix depending on how sparse the map turns out to be. But for now, I think that should be okay, right? Yeah. So then now we have like one. We want to say start X, Y, and 0 for no direction. Maybe 5 for no, or 4 for no direction. And then we just do a direction as you go to right? The 4 directions. Right, so then now we have X, Y, and then D for directions. Right? Yeah. Is that good? Okay, fine, right? So if XY is equal to destination and D is equal to 4, meaning that it's stopped, we can maybe add a constant here for stop is equal to 4, right? If you prefer. Then we return true. Otherwise, we just keep going, right? We go, okay, if D is equal to stop, then we try every direction, right? And we've iterated so that we get the direction. we keep track of direction as well, right? And this is standard standard BFS things, right? And maze of x and y is what is it? Oh, once is a war. No, so we want to go to 0 because that's not a war. Okay. Then and we haven't seen it yet, so we haven't been there yet. Then nx and y, index is the direction, so we haven't been there yet. Then yeah, I think you can actually, I mean, you could do it this way for sure, but we can actually just, if it's stopped, then we just kick it in every direction. So you can actually simplify it a little bit with for index in range of 4, go if x if xy index not in scene, then we just q.append xy index, right? And then we also add it to scene. And then now if it's not a stop, then we just keep going in that direction, right? So right? So dx dy is equal to directions of d, right? So if it is available and we can go it, then we just keep going, right? And that's it. And then return false if we never return true. Okay, so apparently we have a wrong answer. It's because we have this thing, but we don't stop. So okay, so if this is in bounds, well, okay, so this part. Also, this is just wrong. This needs to be if this is not in scene, then we append it, right? But we need an else on this part. The else on this part, it means that it is either a border or it's our bounds, then we stop, right? If we stop, then we append xy stop. But that's only assuming that we haven't seen it yet, right? Because you can just stop and, like, if you're here in this corner and then you kick to the right and then you stop again, then, you know, just keep going, and that's gonna be embarrassing. Try to go, and so it's either war. I don't know why. Okay, let's take a look. I thought this would be done, honestly, so we'll see. I mean, there's a lot of potential for silliness, so I wouldn't be that surprised. Okay, so we just have 0, 4 for 4, so you kick in 4 directions. So you want to go 3, 0, 3, 0, 3. I don't know. This is probably, yeah, it goes to the right, and then now down. Okay, so it does go to 4, 4, but just not 4, 4. Oh no, 4, 4, 4. So then why is it not returning true? XY is equal to destination. Is the other one just false? I thought you could compare. I thought you could compare tuples and lists like this, but maybe I'm mistaken, or maybe like there's some magic that I'm forgetting from somewhere. I just thought it does a pairwise comparison. That's why I wrote it that way without really thinking about it. Because this is slightly more expensive actually than having a tuple, and I still got an issue anyway. Why is this out of bounds? Because we literally checked for it. Oh, okay. That's just me. I don't know. I think honestly, sometimes like I'm talking, and when I'm talking, like I just type stuff without paying attention, and that was just a very silly mistake. Like I typed it way early on and wasn't paying attention. Yeah. What's the complexity here? Well, it's a BFS. It looks at every cell 5 times, right? At most. So yeah, that's it. Or Yeah, for every initial cell, there's 5 different states, and each of those we look at only the 4 neighbors, so not that many times. It's going to be O of n anyway, where n is, of course, the size of the matrix, or the map, or the maze. There's going to be R times C, which is linear. That's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye-bye.